You need to develop, as part of your assignment, you need to develop three null hypotheses. That's your first assignment, so that you have to do three null hypotheses. At the same time, you have to develop three alternate hypotheses. And then you're going to test them. You need to list them for me. You need to say, here's one, here's two, here's three, and each one of them obviously will have an alternate. Okay. And again, don't worry about writing. I have all that information written for you. All right. So let me go back to the original data. All right. There's a rule here about the data. You can use any two variables. You can use height against head circumference, arm span against head circumference. You can use head circumference against resting heart rate. You can use arm span against post-exercise heart rate. The only thing you're not allowed to use is resting against post-exercise. You cannot use them as a comparison variable. For two reasons. One is because I use the data just simply to show you how to do the t-test, and that's considered paired data. Right? That's the reason why. But you can use them in combination with anything else. You cannot use them together, so you cannot tell me that the null hypothesis is that heart rate before exercise is lower than or higher than. There's no difference between the two, because you can see that there is a difference. So you can't use this data, but you can use it in combination with anything you want. Okay? You can separate males from females, and you can compare their resting heart rate. You can separate males from females, and you can use their age and see whether there's something different between males and females. You can use height against post-exercise height rate. You can say tall people have a higher height, post-exercise. You can do anything you want in here. I just need you to develop three, but be careful when you develop them, because if you don't do it properly, you're gonna mess up your own experiment. All right? So that's the first thing I need you to do. All right, so let me show you how to do it. And then I'll let you go, I promise. All right, so I'm gonna go to data. I'm going to go to data analysis. And at the bottom, very bottom, what you see in here, the very bottom, it says t-test, two sample assuming equal variances, t-test, two sample assuming unequal variances. Remember, the one you're using is unequal variances. I'm gonna use equal variances because this is paired data, but I'm gonna use it just for now, just to show you. Okay. All right, so look what happened. I'm gonna click on two sample assuming unequal equal variances. I'm gonna click OK. And then a new window will appear. All right, the first variable will be my resting heart rate. Second variable will be my post-exercise heart rate. All right, I'm gonna click on that particular section. I'm gonna go and highlight the data. I'm gonna unclick it. I'm gonna click the second variable. I'm gonna highlight, you can highlight it anywhere you want, I really don't care how you do it, as long as you get the numbers in it. All right, so notice two things, that the only thing I'm putting in here is the data. Notice that what they call here the alpha is already set, and this is the 95% confidence interval, so please don't change that. That's the one thing for sure, don't do it. All right, whatever it is, if it's a 0.5, leave it at there. Notice that then you have, where do you want your output data? You want it in a new worksheet or in a new workbook. Usually, I leave it as a new worksheet. I want to click OK. I want you to look below here, a new worksheet will be added at the bottom. Not that difficult, guys, I'm just giving you this on it. All right, so there's your sheet. There's your variable. All right, so all I'm going to do is I'm going to relabel the variables. I'm going to say pre-exercise heart rate. Post exercise heart rate, so that I remember. Notice that it gives you the averages for pre and post exercise heart rate. That it gives you the variances, and this is where I need to kind of add a little bit to this. Right, variance is kind of a difficult thing to calculate. What I need you to use it for is you take the square root of the variance. That is equals to your standard deviation. Right, that's the only reason why I'm giving it to you. Because you can calculate the standard deviation, but if you do the square root of the variance, it gives you the standard deviation. Notice that it counts for you, that you how many samples you have, and notice that it tells you that it's full data, so I'm gonna ignore that for a minute. Right, what I need you to do is I need you to look at this particular section right here, that the p-value you're looking for is a two-tail. And the two-tail simply means that you're looking at a graph in this fashion. That's basically what it means, the two-tail. Don't use the t-critical, don't use the one-tail, because the one-tail will be something that looks like, something that looks like, more like that, but it doesn't have the two tails, it only has one tail on one end. So that will be it. Right, so that's what I'm looking for. Here's the value you're looking for. If you know, you don't remember scientific notation, is 1.410 to the negative 17. Right, so it will be 1.49. If you don't remember what that is, please make sure you see me so I can go over it with you if you don't remember your math. All right, so let me go back to the rule now. All right, notice that the value, it says 1.4910 to the negative 17. So I'm gonna go here. All right, so I'm gonna just do this. 1.4910 to the negative 17. So you're gonna say, if my original hypothesis was that there is no difference between pre and post exercise heart rate, the 1.4910 to the negative 17 is way less than 0.05. So I'm going to reject my null hypothesis, but I'm going to accept my alternate hypothesis. Right? That's all you're really looking for. You're going to do this. Once you develop them, you're going to run the t-test, whatever variables you pick, and you're going to tell me what they are. Right, so let me flip back to this. Right, this is the value you're looking for. What you will be doing is the following. And again, this is all be posted in it. I'm going to say null is that there is, no diff. I'm gonna navigate here between pre and post exercise heart rate. Okay, that will be the null, and the alternate will be that there is a difference. All right, I'm going to finish up. You look at the value. You know, you can put the value in there, and all you must do is say either accept or reject as your result. I'm sorry, let me rewrite that. It will be accept or reject. No. You're going to write the whole thing up. That's all you really need to do. Now, this might not make any sense or useful to you right now, but when you do the enzyme experiment, is you get to apply it, then you get to compare data. But that's a little more difficult because that's true data that will have it, but that needs you to sort of practice what you're doing here. And again, I'm posting all these things as an assignment. You have an assignment. It explains about the null, the alternate hypothesis, to give you some examples, to tell you what you need to do. And at some point, you need to run the t-test. And that's pretty much what you need to do. Where you apply it is when you do the enzyme, and that's where it becomes a little bit difficult.
We have to record this to the notebook, or just...
Everything you do from now forward, all you have to do is print it, cut it, glue it on your composition book.
Oh.
You don't need to write anything by hand. I don't want, before we used to do the students do it by hand, all this calculation, all you have to do is run it on Excel, print it, cut it, glue it on your composition book, make sure you tell me on the table of contents what page it is, and I'm done.
Do you tell us to use unequal variances?
Yes,
right?
because it's not paired data.
Oh.
That's why that's why I'm asking you to use unequal variances, because it's not paired data. I use equal because it's paired data, because it's a before and an after. All the data in the first experiment has nothing to do with paired data. It's all variables that are all mumbo jumbo, if you will. They're not paired. Right? They're not before and after. That's why. All right. Don't dwell on this. I wanted to make sure I get it out of the way because when you begin to see, I'm going to post this YouTube video on the assignment as well, somewhere on Canvas.